Biodegradation is the chemical breakdown of materials by the action of living organisms that leads to changes in physical properties. Polymeric components of implantable devices are generally reliable for their intended lifetimes. But no polymer is totally impervious to the chemical processes and the mechanical actions of the body. Generally, polymeric biomaterials degrade because body constituents attack the biomaterials directly or through other device components, sometimes with the intervention of external factors. The process of polymer degradation is made up of pre-implant degradation and post-implant degradation. Generally, polymeric biomaterials degrade because body constituents attack the biomaterials directly or through other device components, sometimes with the intervention of external forces. Absorption and absorption processes usually occur after a device has been implanted. When polymeric surfaces contact with body fluid, they would immediately absorb protein components, and the bulk begins to absorb soluble components such as water, ions, and proteins. The polymer degradation processes are driven by hydrolytic and oxidative mechanisms. Hydrolysis is the process of the reaction of those molecular functional groups and water. They can be catalyzed by acids, bases, salts, or enzymes. Those functional groups are consisted of carbonyl bonded to heterochain elements such as oxygen, nitrogen, and sulfur. The hydrolytic process is mainly host-induced. They may be affected by pH value, hydrolysis, and enzyme. A discussion of in vivo responses of several prominent polymer compositions known to be susceptible to polyesters, polyester urethanes, polyamides, polyalkyl cyanoacrylates. For those polymers containing hydrolyzable pendant groups, one of the most famous is named PMMA, which is used to emboss Siemens and intraocular lenses. Another polymer system with a hydrocarbon backbone usually forms hydrogels in an aqueous environment. It has been used as a scroll balcony. This device is left in place as a permanent implant. It has been introduced into clinical practice in the 1980s. They were apparently performed satisfactorily for years, until in the 1990s, reports of long-term complications of these hydrogel scroll buckles began to surface. The pressures applied to the eye by the swelling have led to blindness and loss of eyeball. They are no longer used in retinal surgery. While much is known about the structures and reaction products of polymers when they have oxidative biodegradation, confirmation of the individual reaction steps has not yet been demonstrated analytically, or just by stress cracking. A process of metal ion-induced oxidation has only been reported clinically for poly pacemaker leads. Under very limited circumstances, the body can transmit electromagnetic radiation that may affect the integrity of implanted polymers, for example, the cornea and vitreous humor of the eye. Metallic degradation occurs in solution. The electrochemical reactions take place on the metal surface. There are always two reactions that occur, the anodic reaction and the cathodic reaction. In all metallic degradation process, the rate of the anodic and cathodic reactions must be the same. The whole degradation process can be affected by preventing either of these reactions. Ceramic degradation is different from metal. Ceramic can be either highly corrosion resistant or highly soluble. Inert ceramic is often used for industrial. Resorbable ceramic can be used for dental component. Aging phenomena, porosity, and dissolution rate can affect the degradation rate of ceramic materials.